Hello, everyone. So, welcome to the first lesson in chapter 1. If you have not watched the introduction video, the one before this, please pause this, go back on Blackboard and watch the introduction video. After that, this is my now second video. And in this, I will be going through the first lessons in chapter 1. Let's see. At least I will plan to cover at least the first 2 pages. If you have not printed them or if you have not downloaded them in one note-taking app, please do that. Be ready to have a similar blank paper or the PDF on your iPad on a separate device from the one where you are watching this video. Okay, be ready with that to take your own notes as you are watching this video. Okay, and as you will see, I have myself inserted some blank pages between each page of these notes for the reason that when I'm teaching, sometimes I want to explain something more or just share some extra information. I'll scroll down and I will write it on the next page. Okay. Otherwise, I will mainly focus on the part here. And let's say, depending on at what space this goes, I might cover more. But the benefit of online learning, one benefit at least is you can pause and you can watch, at your own pace. Feel free to go back, rewind, and listen to the conversation. Listen to the, what I'm saying one more time. Watch what I'm calculating one more time until you understand. Okay, that is the most important thing. Right now, I remembered something. I could have turned, I don't know if there's a way to turn the captions on. I will try that. Language English, caption settings. Okay, font size, I can keep somewhere in between. Right now, I'm just looking at some caption options. Okay. So I don't know if you will see this in the video because I'm recording this in the cloud. Then I might have to download that and share with you. But let me, give my best. And if not, wherever you are watching this video, there might be some option on your screen down where you can generate the captions. Okay, try that if it doesn't come automatically. Okay. I can see the captions as I'm talking here, and it is fairly accurate. So you might also try. Okay. Let's get started. So in lesson 1, we are learning about real numbers and the coordinate systems. Okay. Firstly, natural numbers. So in the development of any civilization, what were the first kind of numbers that people thought of? Okay. Imagine like the hunter-gatherers just starting a civilization and starting to, let's say, rear the cattle, sheep, maybe wild dogs, which they have tamed, or cows, right? And they needed a system to account for, like, how many sheep do I have, and things like that. How many horses do I have, So they, of course, would have started by counting on their fingers initially, but later somebody would have realized that, we have to have some notations. So that is why they are called natural numbers, also called counting numbers. Okay. And it starts with 1, 2, 3, and it goes on. So those trailing dots means it will go on till infinity. Okay, those are natural numbers. And in a different color here, I'm going to write a symbol. Okay, and I want you to take note of that symbol. That n with one extra line is called script n. Okay, that script n is the notation for natural numbers, and it is a very standard notation. Okay, wherever you see this in mathematics, immediately you think of natural numbers. Next is whole numbers. Now, natural numbers are fine. If I have 5 sheep, 6 sheep, I can say that. But what if I don't have any sheep? How do I express that? You have to say, I have 0 numbers of sheep, right? And then you could have 1, 2, 3, and so on. That would be called whole numbers. Okay. And there is a, just like natural numbers, there is a notation for whole numbers. This is W, but it is not a very standard notation. Okay. And in fact, I will tell you something at this point. I'll scroll down to the next page and write something and explain to you some ideas. Just keep in mind, okay? Not whenever I explain some extra stuff, you don't have to take pressure to definitely learn it and understand it. Take it as more like something good to know, okay? Or something fun to know. This the difference is, so what I'm talking about is this. This natural numbers, some people call it just 1, 2, 3. And some textbooks, you will find that 0 is also included in that. Okay, now this might sound confusing initially, but if you give a more serious thought, it's not that confusing. Okay, it's just a question of what convention you want to follow, right? And when people use this for natural numbers, what they will do is they won't talk about whole numbers. That is why I said this is not a standard notation. Okay, so you will have natural numbers and then you directly go to the next called integers, no whole numbers in between. Okay, in these notes and in this book, they have made the distinction between natural numbers 1, 2, 3 and whole numbers which contains the extra 0. Okay, so it's good to know. Next in the line is integers. In integers, we are simply going to take these natural numbers with the 0, the whole numbers, and go on the negative side. Okay, so we will actually start at negative infinity, or something very, very small. No, sorry, very large negative. And then all the way, then you go to -3, -4, -3. You'll go to -2, then you will have -1, then you will have 0, 1, 2, 3, and continue. So the integers would be the natural numbers, the negatives of natural numbers, and the 0 in between. Okay. Rational numbers. The notation, by the way, sorry. In integers, we use this notation, G with that extra line. Okay, again, that is pretty standard notation. So what I'm going to do is I'm going to put these small green tick marks next to the notations which are standard in mathematics. Okay, natural numbers and G for integers. Then rational numbers. Now, as we are thinking of these numbers, you have to understand how these numbers get developed as our civilization becomes more sophisticated. Okay, we have to think of the negative numbers. When you start bartering, and if you are giving something to another person, then you are losing one, right? That becomes -1. And then gradually, we have to also think of dividing single quantity into parts. For example, if we have one loaf of bread and it has to be divided among 3 people equally, let's say, how much will each person get? But if it has to be, if there are 2 breads and you have to divide them among 5 people, how much each person will get, right? Now that becomes, and again, that becomes an important um, thing as we develop. So for that, there is this idea of rational numbers. And what kind of numbers are included in rational numbers? Let me write some examples first. Examples would be like this. 1/2 minus 3/5, 7/9, whatever. Okay, all these fractions basically, will be called rational numbers. And as you might notice, now I'm not writing a particular pattern because there are so many. Okay. So I'll include but these numbers as well. Okay. I'm also including integers in the list of rational numbers. Okay. So as we go down this list, you will notice that from natural numbers to whole numbers to integers to rational numbers, the each successive set contains the previous ones. Okay. And why do I say 0, 1, 3 are also rational numbers? Because even if you wanted to write them as fractions, you can easily do so just by writing divided by 1, right? All these numbers you can write as -3 is -3 divided by 1. So it is as a fraction. You can write it as a fraction, right? These are all called rational numbers. Okay. There is a formal definition of rational numbers, which I'm going to write on the next page, which you might want to keep as extra knowledge. Okay. Q again is a standard notation for rational numbers. You might want to note that. We said that all these rational numbers are fractions, right? How do we how can we describe it? Here is a way. Okay, this is a notation in mathematics, called the set notation. A rational number is any number which is of the form P divided by Q, right? Fraction. But what is that P and what is that Q? It cannot be anything. That P and Q are integers. The numerator and denominator have to be some integer numbers like 1/2, 3/5, -7/5, like that. And there's one more condition. The denominator cannot be 0. Let me erase that. Okay. That collection is called rational numbers. Okay. So that's a very, pretty mathematical definition of what rational numbers are. Good to know. Okay. Or fun to know. Okay. Next, we have irrational numbers. Now, because of this terminology, sometimes students tend to get a notion that the rational numbers and irrational numbers have something to do with like people being rational and irrational. Actually, that is not the case. Okay, it's a misnomer. In the rational numbers, it's because there is a word ratio. Okay, the rational numbers come from the word ratio there. So all these fractions are ratios, right? So they are called rational numbers. The correct way to pronounce it should have been rational numbers. Okay, but although we don't say that. So there is nothing rational and irrational about these numbers. Okay, so all numbers are sensible numbers. Okay, nothing is irrational. But because one type is rational numbers, whatever is not rational number, that is irrational number. In that sense, we call them irrational numbers. All right. Okay. Now, what will be an irrational number? For example, √2. Now, let me change the color of the ink. √2 would be an irrational number. Pi, the number pi that we know, the radius the circumference of a circle divided by the diameter, that ratio is pi and 3.14 and so on. That is an irrational. Okay. And there are other irrational numbers. There's a number called E, which you will see in mathematics quite often. Okay. Its value is 2.78 something. It goes on. That is irrational number. And in general, if you have to come up with more examples, there is a very simple trick. Okay. What you do is you take any number which is not a perfect square, right? Root 2, you take root 3. I'll just put a minus sign here for fun. Okay. Those are also like plus or minus doesn't make a difference. So root 3 is also irrational. But 4, if you take 4 and make it root 4, that is not irrational. Why? Because under root of 4 is equal to 2. That is rational or integer or whole number or natural number. Okay. But then if you go to 5 and make it under root 5, that is irrational. Under root 6 is irrational. Under root 7 is irrational. Under root 8 is irrational. When you come to 9, under root 9 is equal to 3, and that is rational. Now you are getting the idea, right? The next number will be 16. Between 9 and 16, 10, 11, 12, 13, 14, 15, all of them under root will be irrationals, and so on. Okay, those are just some examples. I'm not getting into too much detail here. There are more irrational numbers than there are rational numbers. Maybe just I would say that. Okay, and let that sink in. There are more irrational numbers than there are rational numbers. All right. Okay. At this point, again, I'll go to the next page and talk about something very interesting. So what is the deal with rational numbers and irrational numbers? Sorry, one quick thing, the notation. The notation for irrational numbers is T. And again, not a super standard notation. In some textbooks, you will see it. Some textbooks will not use it. Good to know. Okay. What is the deal between rational and irrational? I'm going to write a number of statements here. Okay. A real number, by the way, we'll be talking about real numbers afterwards, but anyway, we are almost there. So let me talk about it. A real number which is not a rational number is an irrational number. All right. Second thing. So one way to define an irrational number would be, is it a real number? The answer should be yes. Is it a rational number? The answer should be no. Then it is an irrational number, right? A number which is not a real number, which is not rational, is irrational. That is one way of defining. But it's not that it can go in round, right? And then if you have to define what is a rational number, and if someone says a number which is not irrational is rational, that doesn't give you much information, right? So what do we do? One important way to figure out, see the distinction between rational and irrational is via decimals. Okay, so I'm going to make a brief detour here and get into decimals. There are 3 types of decimals. Okay, type A is like 1/2, which is 0.5, or 1/4, which is 0.25, 1/8, which is 0.125, and so on. And that's not just 1/2, there can be more, okay? But such numbers, right? Okay, actually, that dot might be misleading there. But all these numbers, you notice that they're ending, right? 0.5, 0.25. 0.125 and so on. They're ending at some point. And I'll maybe give more example, okay? 0.371, not everything doesn't have to end with 5, no? 0.00 minus 0.00437, something like that. All these numbers which end, okay? These are called terminating decimals. Right, that is category 1. Now, one thing that you will notice about terminating decimals is I expressed the first 3 numbers as both decimals as well as fractions, right? And the next 2 that you see there, 0.371, can be very easily converted into a fraction. And if you ask how, I would say this 0.371 is 371 divided by 1000. As simple as that, just move the decimal by 3 units and divide by that many, 1 divided by that many, 1 followed by that many zeros. Okay, so every such decimal can be converted to a fraction, right? So you can see these numbers are going to be rational numbers. Okay. Next, you have numbers like 1/3. Okay. Now that 1/3, if you write, will be 0.333 and so on. Right? So it's not ending. It is not terminating, but you notice that it is repeating, right? Non-terminating, but repeating. How about some other number like 1/7? Try it. And you have to do this by yourself to get convinced. Okay. You'll see that it becomes 0.142857. You have to, like, you can take a calculator and try it out. And then it will repeat 142,857 and so on. This chunk will repeat. Okay. So again, you are observing that when we say repeating, it is not just one number repeating, it could be a block repeating. And in both cases, you see that they are fractions as well. Now, it will be like too much distraction if I try to get into like how every such repeating number can be converted into a fraction. Later, if I find a good YouTube video for that, I'll post it. Okay. Now, what I mean is this. For example, if I simply gave you something like, let's say, 1.737373 and so on, right? What I'm claiming is if you have such a number which repeats like that, 737373, you should be able to convert it into some P over Q. Okay. But that is not very obvious. What particular P over Q gives you 1.737373? Honestly, like I also don't know at this time, but I know that it is possible to get it. Okay. And there should be some n number of YouTube videos on that. Okay. So what kind of numbers are these? I will write in a different color. These are non-terminating but recurring. We use that word, recurring. Okay. Or repeating, let's say, no? Finally, one last category. You see how many extra things I said that I have already filled out this page. Okay. I'll keep it brief now. The last one will be things that don't repeat at all. Don't end, non-terminating and non-repeating. Okay. Let me write the category first. Non-terminating and non-repeating. Okay. And let's look at some examples. Something like 5. Okay, it is 3.14159 and so on. We don't scientists have calculated trillions of digits after that for pi. Okay, nobody has been able to find any pattern that repeats. It's always changes. Something, the numbers will be that between 1 and 9, 0 to 9, of course, but they will keep changing their pattern. Okay, those kind of numbers are irrational. And now in this list, actually, you would have noticed there are two categories here. So these two, the first two were rational, and the last one here is irrational. Okay. Okay. And at this time, I think the discussion has already made it clear. Real numbers would be rational and irrational together. Okay, all numbers. If you take everything together, we call them real numbers. And like other numbers, it has a very number systems, it has a very standard notation, R, with the extra line there, script R. Okay, so as examples, I would write, let's say √2, that's a real number, 2, a real number, 0, 1/2, -7/5, and so on. All these numbers are real numbers. Okay. Okay. Now here is an exercise that you will do. Okay. I want you to pause the video and do this exercise and then look at my solution, because in next few seconds you'll find that in the video you'll see the solutions. Okay, so pause the video now and do it. What you have to do is take these numbers in this list here and classify them. You see this A, B, C, D, E, F, this category. In each of them, write the numbers that belong to that category. And notice that some numbers will repeat. Now, whatever is a natural number will also be included in the whole numbers, and that will also be included in the integers. Some will belong to only one category. Now, that you have to figure out. And before you start that, one quick thing. Notice here that is 0.245. Okay, there is minus point. There is a point in front of the 245. And this 6/2, comma 8. Okay, there's a comma between 6/2 and 8. Okay, now you pause the video and do the activity. Okay, so check your answers now. So some of this you might have missed, right? I wanted you to go through that exercise. For example, when I wrote 3 there for the natural numbers, that is 6/2, right? The 6/2 can also be written as 3. So when I write it as 3, that's a natural number. Similarly, under root of 81 is 9. So when I write like that, that is a natural number. Then I just include 0, that makes it whole numbers. And you notice that, I wrote that 0, 3, 8, 9 for the integers and included the negative numbers. Now, -14/7 is -2, right? So in that form, it is an integer. Then you go to rational numbers and notice that the decimal we had, -0.245, is a terminating decimal, right? So if it terminates, then it can be converted into a fraction easily. It is a rational number. The only irrational number in the list is under root of 12, because 12 is not a perfect square, right? And then all numbers are real numbers. So everything is in the list of real numbers. Okay, so this is a very good exercise. Think about it, and if you have made some mistakes in your answers, contemplate on that. Okay, before we move on. Okay, now I'll go to the right side of the page, and on this side, you will see we are talking about coordinate system. Okay, now where does this idea of coordinate system comes from? It is a separate topic. It looks like that here, but in a way they are related. At the end of these number systems, we studied the real numbers. Okay, so one thing about real numbers is if you take a straight line and let's say you mark a point there and call it 0, then if you want to make a measurement, like let's say there is a 0 here, and then after some gap there is a 1 here, right? Now you will have in between infinitely many points between 0 and 1, and every point in between there is a real number. This idea you might want to remember. It's a very important idea. Okay, 0 and 1 on a number line. Every point in between is a real number, right? If you are exactly, let's say, halfway between 0 and 1, that is half, 1/2 or 0.5, that is a real number. But if you slide, let's say, this side, that side, you might encounter, like, for example, under root of 1/3, for example, 1/3 is also between 0 and 1. Now, as a decimal, that is a non-terminating decimal, but that number is somewhere there between 0 and 1. And similarly, all irrational numbers between 0 and 1 are also there. Okay. Why am I talking about that? So a number line, a real number, all the real numbers can be represented in a number line. And if you take two such number lines and put them perpendicular, right? You call one of them x-axis, the other one you call it y-axis. They're like two number lines. And then you have this coordinate system. Okay, so what you see here, the rectangular coordinate system that we're talking about is basically two number lines perpendicular to each other, and it has many applications. Okay, so let us begin. X and Y. And as a number line, let me actually write that out here. Any number line will be like that from minus infinity to infinity. So here, this x-axis is also from minus infinity to infinity. And y-axis is also from minus infinity to infinity like that. Okay. Remember, this is a real number line. Okay. Using such two number lines now, you can locate any position on the floor. Let's say, like I'm in this hall and there is a floor. And if I want to pinpoint any location on the floor, I'll need two pieces of information, right? How much left I should move and how much like forward and backward I have to move, left or right, and let's say front and back. That information is captured in this coordinate system. Okay. So for example, this point here, 1, -4, 1, -4. I made a blue dot here. You notice it? 1 to the right and 4 units down. 1, -4. Okay. Then you have 3, 0. 3 units to the right and 0 units up and down. So 3, 0 will be a point on the x-axis like that. And I want you to do this exercise. I'll give you some more points. Okay. So we did this. Let's write some more. So let's say I simply call it number 29. I want you to mark -3, 2. Plot it, and then you can check your answer with me. Do it yourself first. And in number 33 here, I'll give you 5, 3. Let's say. Okay, or we have actually too many 3's coming into picture. Take 4, sorry. 5, 4. Okay. And now check your answer. -3, 2 should be here. That's your -3, 2. And 5, 4 should be here. Okay. Oh, actually one more number. I want you to do one more number. Let's say -2, -1. And when you plot it, check it, -2, -1. I have it. Okay. -2, -1 is here. All right. Now I want you to observe. Okay, make an observation. When you are on this top right, both numbers are positive, right? 5 and 4. Now, if you go to top left, you have a negative number and a positive number, -3, 2. And then you go to bottom left, you have -2, -1. Both are negative. And if you go to bottom right, you have 1, -4. 1 positive, 1 negative, right? And that is not a coincidence, okay? These are called quadrants. So let me write about that here. This will be again an extra piece of information for you. Let me choose actually a different color. I'll go with pink. Okay. This is first quadrant. This is second quadrant. This is third quadrant. And this is fourth quadrant. Okay. That is the naming convention of the quadrants. And each quadrant comes with like what we call the sign. No, it has a combination of signs. In the first quadrant, both numbers will be positive. So you can write ++. Similarly, go ahead and complete that for the remaining 3 quadrants. Pause this, do that, and then check your answer. Okay. Minus plus, minus minus, plus minus. Okay. Now I want you to use that understanding in filling this out. Given the point xy, name the possible quadrant if xy is less than 0. Okay. So let's say you take any point, like let's say -4, 7. Yeah. If you multiply -4 times 7, you get -28, which is less than 0. So in which quadrant it is? In the same way, are there any other possibilities? Pause the video, give a thought, try to figure out. Like now, first, second, third, fourth, which quadrants will satisfy that? And then check your answer. The answer is second and fourth. Okay, think about it. If you have questions, now you know. I have mentioned that in the previous video, Now, suppose you have questions about this. If this is not clear to you, that is when you have to reach out and discuss with me. Okay, I'll be happy to help. Okay, so there is something here. The rest of this page is about using the calculator. And I will not get into that right now. On the bottom side of this page, you see there is homework written here. Okay, you will be doing this homework and submitting it. The students who come to campus, I will give a deadline. Okay, on Blackboard you will be seeing a due date. I will be updating that soon. The idea is simple. If you are coming to campus, which I encourage you to do, you can like bring this homework on a paper to me. That is the best way to submit it, and for me to grade it and give you feedback. So you can use that feedback to improve and do better in your exams. So take a standard print paper. Okay, now don't take random size notebooks. It will be easier for me to file and return it to you if they are all of the same size. Okay, so when I say print paper, you call it A4 sized or letter sized paper, right? The standard one that we use for printing. Take such papers, or if you are tearing from notebooks, make the same size. Okay, don't take some very small or some very weirdly long note. Okay, long notebook. If you need, come to my office. Okay, I can provide that to you. And in that, you will be writing the solutions. You don't have to write the questions necessarily, but make the question numbers clear. And I would actually encourage, I don't know, maybe for the next homework, I'll make the instruction more clear. For now, I'll leave this optional for you. I want to see, how it will be. Write the exercise number and the question number carefully. And by the way, this is from your textbook. When you say page 8, it is the page 8 in the textbook that you have. Okay. And then bring it to my office. Use the discussion thread and Canvas for discussing. If you need to discuss, come to office hours to discuss with me. If you need to discuss, you don't have to struggle on your own. Okay. Try for some time, do struggle for some time, but don't forever. Okay. Then if you need help, come for help. What I'll do is I'll pause this video for now, and in the next video, I'll go to the next page and probably I'll pick up the space. The first video, I wanted to keep it simple. And this is what we had covered in the first class anyways. Okay. Thank you all. I will see you in the next video.